Hello, good afternoon. So, what we're going to discuss today is the continuation of minterm and max term. So, we already had a initial discussion of minterms and max terms. So, this is now the continuation. Okay, so let's discuss the next activity. Okay, so we have letter B here. Generate the truth table of the following given expression. So we have the given was just simply equal to y is equal to a prime b plus b prime c. So this statement, the y is equal to a prime b plus b prime c, is actually a sum of products. So this is actually a min term. Okay? Min terms also called sum of products. So when we say min term, so we have to watch out for an output of 1. So the equation is also in standard form. So how are we going to generate the truth table given that y is equal to a prime b plus b prime c? So take note that the output is y, so we only have one output y here. And the inputs are, so we have a, b, and c. So that's why we have three letters here to represent inputs. We have a, b, and c. So again, so if you have three inputs, okay, so 2 to the n is 2 to the n, where n is number of inputs. So if you have 3 inputs, 2 raised to 3 is equal to 8. So we shall have 8 possible inputs. So we have 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So you have 7 possible inputs here. So starting from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 100, 101, 110, and 111. Okay? So this is in fact in binary sequence. So we're going to do that. Okay? So let's spell out the let's determine the output given the inputs. Okay, possible inputs. Okay, so first term, so this is the first term, so a prime b. So since this is a min term, so in min terms, if the literals or letter is prime, so it means 0. So when we say a prime, so that means a is 0. A prime b, that means b is 1. So we have to take note when a is 0 and b is 1. So let's see. So we have here, okay, so we have a 0, b is 1. So this is a prime b. So whenever we have a 0, b is 1, so we will have an output of 1. Okay, so that's why we have here, okay, a prime b, or when a is 0, b is 1, so we'll have an output of 1. And next we have a prime b next. So you have a is 0, b is 1 here, so we have an output of 1. Okay? So I think that's there's only two. There are only two cases with a is 0, b is 1. Okay? Then next we have b prime c. So when you say b prime c, b is 0, c is 1. So you have to take note when b is 0, c is 1, then you'll have an output of 1. So b is 0, okay? Okay, and c is 1. When b is 0, c is 1, then output is equal to 1. Okay. Next we have b is 0, while c is 1, so we have here another case. So we have when b is 0, c is 1, then output is equal to 1. Okay? So therefore, we have identified the conditions wherein the output is 1, then the rest are zeros. Then you have to type in, you have to write zeros here. Okay? So this now the truth table for y is equal to a prime b plus b prime c. Next we have what if. Okay, so what if for number 2, the given is AB prime plus BD. So again, it's a number 2 example. So number 2 given is, again, in terms of standard form, also in min terms. So when you say min terms, we have the terms, the given terms should have an output of 1. Okay, so we have one output, we have Z. Okay, the output is in Z, and the inputs are A, B, C, and D. So we have 4 inputs. So for 4 inputs, 2 raised to n. So where n is number of inputs. So therefore, if you have 4 inputs, 2 raised to the 4, so you will have 16 possibilities. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 possibilities. Again, these are in binary sequence. Okay, so I'll give you a tip so that you won't get confused with the binary sequence. So in this column, okay, first bit, okay, the least significant bit. So you have an alternate 0 and 1. Okay, so you just write alternate 0 and 1, 0 and 1, 0 and 1, 0 and 1. Okay, and then for second column, you have to repeat 0 twice, 1 twice, again 0 twice, 1 twice, up until here. Okay, so you have up until the 16th. Okay, and then for third column, you have to repeat the 0 4 times, and then 1 4 times, and then 0 4 times, and then 1 4 times. Okay, and last we have repeat 0 8 times, and then the 1 8 times. Okay, so as you can see, there's a repetition of 0 1 in 1 2 4 8 sequence. Okay, so you have to repeat 0 once here, and then 1, and then 0. So there is an alternate of 0 1 here. For letter C, you have to repeat 0 twice, 1 twice, and then 0 twice again. 1 twice, once twice again, 0 2 times, 1 2 times, and then 0 2 times. And then 1 2 4 for letter third column. So you have to repeat 0 4 times, 1 4 times, and then 0 4 times, and then 1 4 times. And then for the fourth column, you have to repeat 0 8 times, and then followed by 1 8 times. So if you have fifth column here, okay, this 1 2 4 8 16. Okay, 16. So it's 16 0, then followed by 16 1. How about here? So you just repeat the pattern here. 8 0 8 1s, followed by again 8 zeros 8 1s. Okay, so you just follow the patterns. Okay, so those are just side notes. Okay, going back here. So the given is actually Z is equal to AB prime C plus BD. Okay. Okay, the first term. So first term is AB prime C. So we call this this is our terms. Okay, another term. So we actually have two terms here. Okay, so AB prime C. So when you say AB prime C, again, take note, this is min term. The given is in min term standard form. So when say AB prime C, A is, we have to look for when A is 1, B is 0, C is 1. Okay, so that's what it means. So AB prime C again is A is 1, B is 0, C is 1. Okay, so when A is 1, so AB prime C. Okay, we have to look somewhere here. Okay. AB prime C. Okay. A is 1, so somewhere here. While B is 0. Okay, so we have 1 0. Okay. And then C is 1. Okay. We have to look for when A is 1, B is 0, C is 1. So definitely not this one, but rather this one. Okay, so when you see A is 1, B is 0, C is 1, then we'll have an output of 1. Okay, so you see we have an output of 1 here. And then another one, A is 1, B is 0, C is 1. Okay, output of 1. Okay. Okay, that's it. So we only have two possibilities for A, B prime, C. And then next we have, for the next term, so we have B, D. So when you say B, D, B is 1 while D is 1. Okay, we have to look for the conditions when B is 1. Okay, but not this one because D is 0. So B is 1, D is 1. So this one. Okay, B is 1 while D is 1, so we have to have an output of 1 here. So we have, okay, this one also. B is 1, D is 1, so we have an output of 1. What else? So B is 1, D is 1, okay. And last we have B is 1, D is 1. So, okay, so we have 4 possibilities, 4 outputs, 4 output of 1s for BD. Okay, so all in all for this given equation, so we'll have 1, 2, 3, 4, 5, 6. So we have 6 outputs of 1s. The rest are 0. Okay. Okay. So 1 and 2, the given are in standard form. So let's say the given is in canonical form. Okay, so for number 4 we have B. Okay, output B. B is a function of xyz. So take note that xyz here is are actually the inputs. Okay, it's equal to pi. So when you say pi, so the given is in max terms. 2, 3, 5. So those are the max terms number. So it's actually easier to generate the truth table given the canonical form. Okay. So bxy, so that means we have 3 inputs. Again, 3 inputs, 2 to the n, 2 raised to n. Okay, we're n number of inputs. So we have 3 inputs here, x, y, z. So 2 raised to 3 is equal to 8. So we have 8 possibilities here. Okay, counting from here up until here. So you have 8 possibilities. Okay, starting from 0 to 7, it's actually 8 possibilities. Okay, and then pi of 2, 3, and 5. So that means for these max terms numbers, so the output should be equal to 0. Okay, so let's see for max terms 2, we have 0. For max terms 3, we have 0. And for max terms 5, okay, so max terms 3 is 0, max terms 3 is 0, and max terms 5 is also 0. The rest are 1. Okay, so it's easy to generate truth table given the canonical form. Okay, so that's it. So I have answered 1, 2, and 4. So that means the rest 3 and 5 assignment. Okay. Okay, how about letter C? Okay. For letter C, generate the truth table of the following canonical forms, then simplify using Boolean theorems. Okay, so the number 1 is just like what we recently finished this one. Okay. But the difference is we have to simplify, we have to do some simplification using Boolean algebra. Okay, so again, output A is a function of xyz is equal to pi 017. Again, pi means max terms. Okay, so when you say max terms, so for the given terms, the output is 0. Okay. So xyz again, so we have 3 inputs, so therefore you have 8 possibilities. Okay, starting from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 100, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, so we have start with maxterm 0, the output is 0. Next, maxterms 1 is output of 0. And lastly, we have maxterm 7, the output is 0. The rest are 1s. Okay? And then it says here that we have to simplify using Boolean theorems. Okay? So using Boolean theorems, okay, for the first term, okay, first max terms. So for max terms, so if you have an input of 0, it is unprimed. Okay? Whereas if you have an input of 1, that is prime. Okay? So max terms is opposite of min terms. Okay? So example here. Max term 0. So x is 0, y is 0, z and 0. So it is represented by x, y, and z. Then x plus y plus z. Okay. Because max terms is actually a product of sums. Okay. So you add first, then you multiply. Okay. So again, for first term, max term 0, we have x plus y plus z. Okay. Next term, max term 1. Okay. With max term 1, x is 0, y 0, z is 1. So we have x plus y plus z prime. Okay. Take note that the 1 is prime. Okay. Whenever the input is 1, so that is prime. Okay. Times, so you have the third term. X is 1, y is 1, z is 1. So we have when x is 1, so we have x prime plus y prime plus z prime. Okay? So we have 3 terms. Okay? So we have again, when term is max term 0, so you have x plus y plus z. When for max term 1, so we have 0, 0, 1, x plus y plus z prime. And for max term 7, we have x is 1, y is 1, z is 1. So we have x prime plus y prime plus z prime. Okay, let's continue. Okay, then let's associate the first two terms. Okay, so let's operate on the first two terms first. We'll start the simplification process by distributing. Okay, start with x, distribute it here, and then followed by y, and then z. Okay, we'll do it step by step so we won't get confused, we won't get lost. Okay, so we distribute the x first to the second term such that we have, okay, xx plus xy plus xz prime, and then distribute y to the second term. We have plus xy plus yy plus yz prime, and then distribute z to the second term. So we have xz plus yz and zz prime. Okay, and then just copy the third term. Okay, so we have it here. Okay, so simplify. Xx is x. Okay, x is x, then copy xy, then copy xz prime, then xz. Okay, you have it here, xz. Then yy is y. Okay, we have 2xy, xy plus xy is also xy. Okay, then we have yz prime, copy yz prime here, and then yz. Okay, so and then zz prime is 0. Okay, z times z prime is 0. Okay, then, okay, so that's why we have here. So we have x plus xy, so associate that, plus xz prime plus xz plus yz prime plus yz, and then just copy the third term. Okay, then we have the x plus xy. Okay, so we have this Boolean algebra. X plus xy is equal to x. Okay, and then for xz prime plus xz, so we factor out x. Factor out x times z plus z prime, then plus y, plus again factor out for this one yz prime plus yz, so factor out y, so y times z prime plus z. Okay, and then copy the third term. Okay, so z plus z prime is 1. Okay, we have z prime plus z is again 1. So what is left is x plus x times 1 plus y times 1. Then just copy the third term. Of course, okay, x times 1 is x, y times 1 is y. So such that we have x plus y plus y. Then the third term. Copy the third term. Okay? So x plus x is x and y plus y is y. And okay? So the first two term is reduced to just simply equal to x plus y. Okay? But we're not yet finished. Okay? So we're going to distribute the x plus y to the third term. So we're going to distribute it here such that starting from x, okay, so distribute x, so we have xx prime, xy plus xy prime plus xz prime, and then distribute y, we have x prime y plus yy prime plus yz prime. Okay, is equal to, so xx prime is 0, so xy prime copy, okay, followed by xz prime, so we have xz prime here, then x prime y, yy prime is 0, and then you have, lastly we have yz prime. Okay, so we have eliminated xx prime and yy prime. Okay, so we have 1 2 3 4, so we have 4 terms remaining. So we associate again xy prime plus x prime y. Okay, so although this cannot be reduced anymore, but if you, whenever you see this term, so xy prime plus x prime y, it can actually be expressed by a single IC, single gate logic gates, which is the plus XOR. Okay, XOR is signified by a plus inside the circle. So whenever you see this symbol, so plus inside the circle is actually XOR. Okay, so this can be it means x or y. Okay, plus okay, for this one, z prime times x plus y. Okay, so from 1 2 3 4 5 6 7 8 9, so from 9 literals we're able to reduce it to 1 2 3 4 5 literals. Okay, so it's important to reduce the number of literals to simplify the circuits. Okay, implementation of circuits. We're going to do the circuit in using breadboard. Okay, so the lesser the literals, the better. Okay, so again, so for multiplication, so we use AND gates. For plus, we use OR gates. Okay, for prime, we will use inverter or NOT gate. But for this, okay, plus inside the circle, so it's an XOR gate. Okay, so we'll have that next meeting. Okay, so it's actually discussed here. Okay, so logic gates. Okay, so AND gate is for multiplication. Okay, this is the diagram for AND gates. Okay, and then NAND gates. And then OR gates. Yeah. So we have OR gate 7432 IC. And then we have XOR. Okay, so this is the XOR 7486. So this is symbol for XOR. So whenever you see the characteristic of XOR is that it has an output of 1 whenever the inputs are different. Okay, so you have 0, 1 or 1, 0, the output is 1. Okay, and XNOR, okay, this is a symbol for XNOR. So you have a dot inside the circle. So whenever you have the same inputs, so let's say both 0 or both 1, the output is 1. Going back to the topic. Let's go back to the topic. Why do we okay? Okay, so let's have one last example. Okay. Okay. So last example here. The given canonical form is C is equal to XYZ is equal to epsilon or summation of 1, 2, 6, 7. So whenever you see epsilon, so that means that for these are minterm numbers. Okay, minterm numbers. So these numbers has an output of 1. Okay, output C is a function of inputs X, Y, and Z. Okay, X, Y, and Z. So we have 3 inputs. Okay, X, Y, Z. We have 1 output C. Okay, so again we have 3 inputs. 2 raised to n, where n is 3. So 2 raised to 3. So we have 8 possibilities. Okay, for minterm numbers 1. For minterm numbers starting from 1, so we have an output of 1, 2, 6, and 7. Okay, 1, 2, 6, and 7. Then the rest are 1. Okay, so then simplify. Okay, for minterm 1, so we have x is 0, y0, z is 1. So x is 0, y0, z is 1. So we have x prime, y prime, z. Okay, plus, okay, next, x is 0, y is 1, z is 0. So we have here x prime, y, z prime. Okay, and then we have 1, 1, 0, x is 1, y is 1, z is 0. So we have x, y, z prime. Okay, so we have x, y, z prime. And lastly, we have for 7, we have x is 1, y is 1, z is 1. So we have x, y, z. Okay, so we have 4 terms. Okay, then associate the x prime, y prime, z plus x, y, z. Then associate the last 2 terms. So we have x prime, y, z prime, and x, y, z prime. Okay, so we do the necessary association for possible, what do you call this? Factoring. Okay, factorization. Okay, so for this equation, so we factor out letter z, factoring out letter z. So we have x prime, y prime plus xy. And then for this one, we factor out yz prime. Okay, yz prime times x prime plus x. Okay, so x prime plus x is x prime plus x is 1. Okay, so that's why we have simply equal to yz prime here. But whenever you see this condition, so x prime, y prime plus xy, so it's actually an x nor. Okay, so x nor. So you have the dot inside the circle. So it's actually an x nor. Okay, z times x nor y plus yz prime. So how are we going to implement that? Okay, so again from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so from 12 literals, we are now down to just 1, 2, 3, 4, 5. So Okay, so let's try to implement this. So starting with x nor y. Okay, so this is a symbol for x nor. Okay, so we have, let's say you have a two input x nor. Okay, so x and y, so we have x and y here. Okay, so the output of this is x nor y, or this one. It's already in this term. Okay, and then after this one, okay, it will be ANDed to z times z. Okay, z times x nor y. So, to implement multiplication, so you need an AND gate. Okay? So, the output of x nor is to be inputted to AND gate. And then the other input, okay, so we have two inputs here. So, it will be sourced from z. Okay? So, you have an input z. Okay? So, therefore, the output of this is z times x nor y. Okay? X nor y, x nor y times z. So, the output of the AND gate here. Okay. So, next term, we have yz prime. Okay? But first, okay, so you have to invert the z because it's in prime. So, to invert z, you need an inverter. Okay? So, the input of z, the input of inverter is z. Then the output of that would be z prime. Okay? Z prime times y. Z prime times y. So, times or multiplication. So, you need an AND gate. Okay? AND gate. So, the output of inverter is to be inputted to the AND gate. And then, the other input would be top 2 input y. Okay? So, that's why, okay. So, the output of this second AND gate is now equal to yz prime. Okay, so we now have two terms here. Okay, we now have values for, okay, what else? So how we're going to connect these two terms? So to connect these two terms, you need a plus. Okay, so plus is to be implemented by an OR gate. Okay, so that's why we have an OR gate here. So the output of this, so this is this gate, AND gate. The output of this AND gate is x nor y times z, while the output of the second AND gate is yz prime. So, the output of these to be inputted to OR gate, and likewise this one. Okay, and the result is the output of this OR gate would be equal to z is equal to x nor y times z plus yz prime. So, if you have numerous literals here, so you'll have more wirings, okay, more inputs. Okay, so it will be more tedious to do the circuit. Okay, so take note that in logic circuits, okay, so whenever whenever there's connection, you just put a heavy node. Okay, so you just put a heavy node here, this one also. Okay, so intersections of lines just like this one means no connection. Okay, so if you want to connote that there's a connection of the line, so you have to put a heavy node. Okay, okay, so we have now assign that's all for now. Okay, so we'll have a continuation assignment. So I have assigned an assignment, okay, for this. Okay, also have an assignment for letter C. Okay, and then for letter C, so aside from the truth table, simplify, you have to draw the circuit. Okay, so that's all for now. Okay, so see you next week. Bye.